Hello students, this is Mr. Hart. In this video we want to finish up our unit on algorithms and data by talking about data. Okay, so you probably just think of data in terms of maybe the data on your phone, the amount of data you can download and upload with videos and searching stuff while using the internet, right? Maybe you have a data plan for your phone. Maybe you think about data in terms of the stuff stored on your computer or on your phone. And that is all very much true. But in terms of algorithms, we want to think about data in terms of how we're using it and how we're storing it. Okay, and obviously we just think of, oh, we have files and we use those files for opening photos on my computer or running programs. Okay, but the way those are stored actually matters a lot. Okay, so we want to look at three types of data that a computer actually uses and understand when we would use them. Okay, so the three main types of data that a computer and a programmer use are a list, a set, and a dictionary. Okay. Now, a dictionary sounds weird because we use dictionaries for look up words, but it actually has a particular meaning in programming and in algorithms. Okay. So first of all, a list, again, a data set where order matters, right? If you are waiting in line at Walmart to, get your shopping done or whatever, or waiting in line at a restaurant, you want to be served in the order that you get there, right? First come, first serve. You don't want to get there and then have someone cut in front of you and they just pull someone random from the lobby and say, okay, you're next, right? You want that order to be honored, right? So data sometimes needs to have a specific order when it's put in, and we want to keep that order. Okay, a set is the same, but an order doesn't matter. So it's just a list of things. That sounds weird, but a set of things, a part of data that doesn't matter what order it is in. And then a dictionary is a data set where you may have multiple parts stored with each item. Okay, so let's go through them in more detail. So list is, again, a data set where order matters. To be particular, in computer science, we usually represent that with square braces. Okay, so you'll look down here at the list I have listed. Okay, I have square braces on here, which means the order does matter. So whatever data this is, a set of names, right, a list of names, I should say, they were put in this particular order for a reason. So maybe this is, again, the restaurant line. I get served first because I came first, and then she does, and he does, etc. Okay. And so any kind of waiting list or serving list, any kind of queue, you're going to use a list data. Okay. And again, square braces represent that. Okay. Another example of this would be processes on your computer. Let's say you open up one program and then right after you open up another program. Your computer is probably going to honor that you're trying to open up this program first and then open up that program. Okay, it'll put that information in a list. What has the user clicked on? And I'll do those things in that order. Okay. A set is, again, a data set where order doesn't matter. It's stored in the same way, but the list stays sorted for easy lookup. Okay, so it's still just memory, right? Your computer just has files. You can only put them in a list, basically. But it keeps it sorted so it can quickly look through and see if a certain member of the data set is in there. Okay. In this case, we generally use curly braces when we mean a set. But for example, this might be a set of songs that are available on iTunes, okay, or some other music service. It doesn't really matter the order they were put on iTunes. You don't really care about what year or what day they were put on iTunes. You just care that they're available for purchase, or maybe they're available in your library. Okay, so in this case, bonus points if you happen to recognize the singer. This is all songs by James Taylor. Okay, all these songs are available in my music service, so that is stored into a set. Okay, I don't care when they got there. I only care that they are there. They're available. I can use these pieces of information. Okay, so sets are always sorted for easy search. Okay, and again, you just want to find if something is available. Okay, and then last of all, what we call dictionaries. Sometimes they're called maps. I don't like that name as much. I like dictionary, but it's where the order doesn't matter, but you can have multiple parts, okay? And you still use curly braces, but you include colons inside when you're representing that kind of data set. So very common one is usernames and passwords. So you don't care which users came to a service first. So let's say you're logging into your email. Google does not care if you came back in 2001 or if you got an email address yesterday. They only care that you're a user, right? So they're going to store that as a dictionary where each username will be associated with a password, okay? And maybe associated with, a phone number or things like that. So you'll have one piece of information associated with other pieces of information. So here's all the people and their usernames. Here's all their passwords, okay, etc. Okay? So lots of things use dictionaries when they need to associate one bit of information with another, but they're generally not ordered, right? They need to just be unordered. It just needs to be a set, but the pieces have multiple parts to them. Okay? Let's go through some examples in some games that you guys may have played. Okay, so let's think about the most basic of games, Super Mario. Okay, even if you don't play video games, hopefully you've at least heard of this game. Very popular, right? Kind of started a lot of gaming for a lot of people back in the 80s. Okay, but Mario, right? He runs around the screen, he jumps on Goombas, he hits and gets coins. Okay, so things are stored in different ways that matter. Okay, so for example, what if you wanted to store what is inside each box in the game? Okay, well, you don't want it just to be random, right? You need that to be a particular set, right? Or a particular order. Okay, it's kind of set in stone. This box has a coin, that box has a star, that box has a mushroom, whatever. Okay, so you'll probably store that information in a list of this box came first, it has this box came first, and then that box. Maybe you store it in a dictionary if you have an ID, so maybe it's box number and item stored in a dictionary. So that's one possibility. Okay, maybe the guys on the screen, they each have points associated with them, right? If you kill that Goomba, you get 100 points, right, for the score. So you'd probably want to store that as a dictionary. This character is worth this many points when you jump on them or whatever, right? And so that would probably be a dictionary. Okay, so dictionaries are very common in video games. Okay. Another example is maybe Minecraft. If you've ever played a crafting game, you know that maybe you have a whole bunch of things you gather, right? The game doesn't really care about the order that you gather them, right? So it probably stores the things that you got as a set, right? You have this much of tree and grass, you have this much of stone, you have this much of whatever, right? All the things you gather is probably stored as a set. It doesn't really care the order that you got them in. It cares more about how much you have, right? What elements you have. Okay? Maybe the things you can craft are a dictionary, right? For this item, I need this many of wood and this many of stone, etc. And for this item, I need this many of wood and this many of stone and this many of tree or whatever. Okay? So that list of what you can craft is probably stored as a dictionary. Okay? And where things are placed on the level, that's probably a list somewhere. It's probably a big three-dimensional list, right? Kind of because the world gets put at random. But once it's built, it kind of needs to be set in stone. So that might be a list for the order of where things are placed. Okay? So again, just think about it. There's different times and different places that you would need to use different types of data. Okay? So let's try a couple more. Just things you probably use every day. Okay? So example 1. So a group of users that use Facebook and their passwords, email addresses, birthdays, etc. Okay? If you think about it, I need to associate a group of users with other pieces of information, right? So that's probably a dictionary. Okay, so example 1 is a dictionary. Example 2, your browser's web page history ordered by time visited. since it's ordered by time visited, it probably is stored as a list. As you go through pages, it just adds them to a list of your history. Okay, so your browser web page history is probably just a list of information. Okay, and then number 3, a data set of items found at a particular museum. Again, you don't really care about when they got there, probably don't even care what room they're in, that type of thing. So it's probably just a set. Okay, these are the items that are available to be seen. Okay, so there you go. That is how we think about data, and that is your homework, is to practice more of associating which type of data should I use in which scenario. Okay. The last thing I want to talk about in this unit is just a little bit of how do you test an algorithm. Okay, if there's an algorithm you're using to solve a problem and it's not working, what do we do? Okay, this will definitely come up when we do programming later on. But it's good to start thinking about this now, because you can use it in more than just programming. You can use it in diagnosing any kind of problem. Maybe you own a house someday and there's something wrong with your refrigerator, or there's something wrong with the electricity, or whatever it may be. Maybe something's not printing right. Whatever it may be, you can always use this to test processes, right, and see what's going on. Okay, so here's some basic tips whenever you're trying to debug an algorithm or something like that of what you can do. Okay, the first is you can always try multiple inputs. Okay, maybe something you're doing, you want to solve this particular solution of this problem, but maybe there's something wrong that you can't see in that particular solution. Okay, so maybe you want to try as many combinations to see what works and see what doesn't. Okay, so I wouldn't recommend doing this with the electrical in your house by any means or anything like that. But maybe you're trying to plug in some numbers to your algorithm and some numbers just aren't working. Well, plug in as many possibilities as you can, and maybe the pattern of when it works and when it doesn't is going to tell you something, right? Maybe all the odd numbers in your algorithm don't work and all the even numbers do. Maybe that reveals something about how odd and even numbers are set up in the algorithm. Maybe there's something you need to change to odd numbers, something like that. Okay. Maybe you're running a program on your computer and it always crashes if your browser is open at the same time. Okay, try it without the browser open. Try it with other programs open. Try it just by itself. Does it crash in different cases? Is it always the browser? Is it maybe just when something else is open? Okay, try different combinations and see if that will help you figure out what's going on. Okay. Another thing you can do is start from the end and work backwards. So maybe you're building a big complicated machine and it doesn't do what you want. Start removing parts from the end of your machine or your algorithm or whatever it may be and see when it starts working. Use this to figure out where the problem is, right? So again, maybe you're trying to turn on your computer and it always crashes right before it gets to the home screen or something. Well, maybe try and see exactly when that crash happens. Does it happen when it boots up the monitor? Does it happen when it boots up something else, right? So maybe going back from the crash would be helpful. Okay, or maybe you're doing again an algorithm and it always fails on the last step. Well, figure out going backwards which steps are working, and maybe that will help you figure out where the connection is broken or something like that. This is someone that works for electrical in your house, right? Maybe all the rooms' lights work except for one room. Okay, well, go back through light switches until you get to ones that don't work, or to the ones that do work, and figure out where the disconnect happened. Okay. And then another one you can do is start from the beginning and work forwards. So start adding parts to the beginning of your algorithm. When it stops working, there's a problem. Okay, so again, maybe this is building something or working with something. Start from the beginning. Okay, build up the pieces slowly and then see when it breaks down, and that will help you figure out what you need to fix. Okay, so again, we'll come back to these, but I think they're important for just any problem you're trying to solve. Sometimes the solution you come up with just doesn't work. It's important, especially these two. Go from the beginning, or go from the end backwards and go from the beginning forwards and see if you can find where that disconnect happened. Okay. All right. So that's it for this unit. Thank you guys so much. In the next lesson, the next unit, we're going to finally start with some basic programming stuff. Really excited for that. So I'll see you guys then.